In our daily life, we have come across glasses or buckets which are generally used for drinking water and buckets which are used to fill water. Can you guess the shape of the objects being displayed? Objects that have two circular ends with different radii are called frustum of a cone. Now, let us do an activity to create a frustum of a cone ourselves. Take a right circular cone. Slice or cut through it with a plane parallel to its base. Now remove the smaller cone that is formed on one side of the plane. You are left with a solid that is a frustum of a cone. What are the parts of the frustum of a cone? A frustum of a right circular cone has two unequal flat circular bases and a curved surface. Here, R1 is the radius of top of the frustum and R2 is the radius of the base of the frustum, where R2 is greater than R1. The height or thickness of a frustum is the perpendicular distance between its two circular bases, and the slant height is the length of the line segment joining the extremities of two parallel radii drawn in the same direction of the two circular bases. Frustum of a cone is the solid obtained after removing the upper portion of the cone by a plane parallel to its base. How can you determine the area and the volume of the frustum of the cone? Let us recap on how the frustum of a cone was formed. Take a bigger cone of height h1, radius r1. When sliced by a plane parallel to the base, we get a smaller cone and a frustum of a cone. The smaller cone is of height h2, radius r2. Here, the frustum of a right circular cone is obtained by slicing off a bigger cone with a plane parallel to its base and discarding the smaller cone. Surface area of the frustum of a right circular cone is equal to the difference of the surface area of bigger right circular cone VAB and the surface area of the smaller right circular cone VA-B'. The formulae listed below can be derived using the idea of similarity of triangles. The curved surface area of frustum of cone is equal to pi r1 plus r2 into L, and the total surface area of frustum of cone is equal to pi L r1 plus r2 plus pi r1 square plus pi r2 square. Similarly, the volume of frustum of a right circular cone is equal to the difference in the volume of bigger and the smaller right circular cone. Substituting the formulas for volume and simplifying, we get volume of a frustum of a cone is equal to 1 by 3 pi r1 square plus r1 r2 plus r2 square into h. YB wears a Turkish hat, the fez, which is shaped like the frustum of a cone. If its radius on the open side is 10 cm, radius at the upper base is 4 cm, and its slant height is 15 cm, find the area of material used for making it. Can you find how much cloth is required to make my cap? YB's hat is in the shape of a frustum of a cone. Here, it is given that the radius of the open side is R1, that is 10 cm, and the radius of the upper base R2 is 4 cm. L is equal to 15 cm. To find the area of the material used for making the cap, we have to find the curved surface area of the frustum of cone. What is the formula to find the curved surface area of the frustum of a cone? The curved surface area of the frustum of a cone is pi into R1 plus R2 into L. Substituting the known values in the above equation, we get curved surface area equal to 660 cm square. To find the area of the material used for making the cap, we also need to find the area of the circle. What is the formula to find the area of the circle? Area of the circle can be found by using formula pi r square. If the radius of the circle is 4 cm, then area of the circle is 22 by 7 into 4 square, which is equal to 50.28 square centimeters. Area of the material used for making the cap is equal to curved surface area of the frustum of the cone plus area of the circle. Substituting and simplifying, we get area of material used in making the cap is equal to 710.28 centimeters square. A container opened on the top and made up of a metal sheet is in the form of a frustum of a cone of height 16 centimeters with radii of its lower and upper ends as 8 centimeters and 20 centimeters respectively. Find the cost of the metal sheet used to make the container if it costs Rs 8 per 100 centimeters square. Find the cost of milk which can completely fill the container at the rate of Rs 20 per liter. The container is in the shape of a frustum of a cone as shown in figure 1. It is given that R1 is equal to 20 centimeters, R2 is equal to 8 centimeters and H is equal to 16 centimeters. We know that the slant height L is given by square root of h square plus R1 minus R2 the whole square. Substituting the given values of R1 and R2 and H, we get slant height L as equal to 20 centimeters. Now, to find amount of sheet required to make the container, we first have to find the surface area of the frustum of the cone. We know curved surface area of the frustum of a cone is pi into R1 plus R2 into L. Substituting the known values and simplifying, we get curved surface area of the frustum of the cone as equal to 1760 centimeters square. Surface area of the open container is equal to curved surface area plus area of circle of radius 8. Surface area of the open container is equal to 1760 plus 22 by 7 into 8 square. Surface area of the open container is equal to 1760 plus 201.14, that is equal to 1961.14 centimeter square. Cost per centimeter square is Rs 8. Cost of 1961.14 centimeter square is 8 into 1961.14 divided by 100, that is equal to Rs 156.89 paise. We know volume of a frustum of a cone is 1 by 3 into pi into R1 square plus R1 R2 plus R2 square into H. Substituting the known values, we get the volume of frustum of cone as equal to 10.45 liters. So, the cost of milk to completely fill the container is 209 rupees 18 paise. Here, we have calculated the cost of metal sheet required to make a frustum of a cone as Rs 140 and 80 paise and the cost of milk to completely fill the container as equal to Rs 209.18 paise. Now, let us do another problem. An oil funnel made of tin sheet consists of a 10 cm long cylindrical portion attached to a frustum of a cone. If the total height is 22 centimeters, diameter of the cylindrical portion is 8 centimeters and the diameter of the top of the funnel is 18 centimeters, find the area of the tin sheet required to make the funnel. For cylindrical portions, the diameter of the cylindrical portion is 8 centimeters. So, the radius is 4 centimeters. For the top portion, which is in the shape of the frustum, it is given that R1 is 4 centimeters, R2 is 9 centimeters and H is 12 centimeters. Now, Km is equal to 9 minus 4, that is equal to 5 centimeters and Kn is equal to 12 centimeters. In triangle KMN, applying Pythagoras theorem and then substituting and simplifying, we get slant height L is equal to 13 centimeters. Now, the area of tin required is equal to the area of the entire oil funnel. So, the area of tin required is equal to the sum of the surface areas of the cylinder and the surface area of the frustum of a cone. Substituting the given values and simplifying, we get area of tin required to make the oil funnel is equal to 782.57 centimeters square.